Hello everyone, I'm Zoe. I'm back with another example of radicals. This time we have a division of two radical expression. Uh, we want to use the rationalizing denominator and use this fact, but how can we simplify this one? This is two terms, divide by two terms. On the denominator, uh, we have clause here. It means two terms. We cannot simplify right this one. But when we have two radicals on the denominator with plus or minus between, we use this difference of squares. If you remember this one we had before, if we have two factors, two parentheses, one is sum of two numbers, the other one is difference of two numbers, the result is the first one squared minus the second one squared. This is very useful to rationalizing denominator. We call this rationalizing denominator. And in future you can use this one for simplify any kind of radical when you have radical on denominator. Okay, now what can we do? We can find the conjugate of this one. If this is plus, then this is plus, the minus between is conjugate of this one. This is conjugate to this is conjugate to this. Okay, we find this. We can write 2 rad 5 minus 3 rad 7 over we write this one multiply, but conjugate of this is 5 rad 6 minus 4 rad 2, and as well we must do this here because actually this must be 1, so the denominator and the numerator must be the same. Okay, what can we do? With use of this, using this one, this a plus b times a minus b, we get the first one squared, 5 rad 6 squared, minus the second one squared, yeah, 4 rad 2 squared. The top is multiplication of these two, 2 rad 5 okay, I come back here and continue with another color. Okay, how can we do that? On the top we have two terms by two terms. Just distribute 2 rad 5 times 5 rad 6. The index are the same, we can do this. 2 times 5 gets 10. Rad 5 times rad 6 gets rad 30. Are you with me? Good. 2 rad 5 times 4 rad 2 minus 8 rad on the radical 5 times 2 gets 10. I have a second one. Negative 3 times 5, negative 15. Rad 7, 6, 42 on the radical. Negative 3 times negative 4 plus 12. Rad 7 times 2, 14. But on the bottom, here everything is much simpler because we rationalized this one, and we have the first one squared gets 25, this 25, and 6 squared comes out and gets 6. 25 times 6 minus 4 squared gets 16, and 2 squared comes out and gets times 2. Hope you're following me. Good. On the top, 10, on the radical is 3 times 10 or something, but we can't simplify this because nothing coming up and nothing comes up because this is 10 times 3, 5 times 6 is not completely squared. This one is 10, 5 times 2, 6 times 7, and this one, 7 times 2 is not complete. So we can get this one as the same. Minus, actually we write here, easiest. Okay. The top is the same because we can simplify under. 15, this is 42, 3 maybe comes 42. No, it's not coming out. Okay, 42 plus 12 radical 14. On the bottom, 25 times 6 gets 150. 16 times 2, negative 32. And the answer is on the top, everything on the top. You have me here. Yes, minus 15 at 42 plus 12 at 14 over 118. This is the final answer. We couldn't simplify here because under radical we couldn't simplify, neither simplify or adding this multiples. Okay, because we need to have a same radical and the same index. Index is okay, but under radical is not the same. Okay, hope you like this one, and go and practice more about the rationalizing denominator. Rationalizing denominator is very useful method because in mathematics and algebra, when you get radical on denominator, you need to remove that one. The only way to removing this using this difference of a squared. And good luck, and don't forget to subscribe the channel if you think this is useful. Bye.